Okay. Okay, so I hope you can see my screen. So this is the brief description of the book by Antonio Lieto, Cognitive Design for Artificial Mind. The book is really interesting and explains the crucial role that human cognition research plays in the design and the realization of artificial intelligence systems. Okay, and more about this book. I am Antonio Chella, I am from the University of Palermo, and I am also a research associate from the ICAR CNR, which is the Italian National Research Center. And I am also an honorary professor at the University of Manchester since this year. Okay, Antonio Lieto is the author of the book. He's a tenure track senior researcher at the University of Turin, and he's also a research associate at the same institute in Palermo. So we met some time for his activities at this institute. And Antonio is also an ACM distinguished speaker and and the other panelists are Professor Pollit-Cham, which is professor in digital transformation design and School of Media, and from the University of Brighton. And other panelist is Shiwali Mohan, which is a senior member of research staff at Xerox Parc in Palo Alto. And Shiwali is a former member of the SOAR laboratory led by John Lurch. She's an expert on architecture. And David Peebles, is the director of the Center for Cognition and Neuroscience at the Department of Psychology at the University of Huddersfield. Okay, so here are the panelists, and more or less this is the schedule of this event. So now Antonio will, in a few words, will present the book, and then we will have a first round table for the book by night. So each panelist can say a few words about the most important thing about this book. Then we prepared some questions. We have some questions. We all agreed on some questions in order to break the ice and start the discussion. And finally, we have questions from the audience. Okay, so I think that we can I virtually pass the virtual microphone to Antonio.
Okay, so thank you, Antonio, for the introduction. I'll try to share also very few slides before leaving the ground to discussions. And let's see what happens. It's always a mystery. So you should be able to see now the slides. See it? Can you see my slide?
Yes, we can see the screen.
Okay, great. So first of all, I would like to say thank you to you, Antonio, and to all the panelists for this discussion, because it's really an honor for me to have all of you here. So in a nutshell, the idea of the book is driven by some questions, which are the following ones. So what are the elements that characterize cognitively inspired AI systems? What are examples of cognitively inspired AI system, and how do they differ from standard, let's say, technologies? Finally, let's say the other questions which were really driving my my research and the writing of the book is how this system can really be used, and how can they compared, let's say, ranked also and evaluated. And finally, how this kind of cognitively inspired approach can help to develop the next generation of AI systems that go beyond deep learning. Because I think this is a really important question, not only for the cognitive modeling community, but also in general for the AI community. And in particular, the book is collocated within the framework of cognitive AI or computational cognitive science, according to which the idea is to build artificial system by taking inspiration from how natural system, let's say, achieve the same kind of goals or perform the same kind of task. On one end, there is this inspiration part. On the other end, there is the explanation part. So the idea is that by using this kind of inspiration, the simulation that we can obtain with the artificial system can also provide a sort of reverse inference, so a sort of additional knowledge with respect to the theories that we have taken into account and that explain, for example, a given phenomenon in animals or also in humans. So in order to, this is a very well-known loop that goes back to the cybernetic tradition, but in the book, the first distinction that I think is relevant is the distinction between functionalist and structuralist artificial models. So this is a very well-known dichotomy, but in a nutshell, the idea is that with a functional system, you share with the natural system only the same input-output specification and a very surface resemblance of how the internal components of the artificial system are assembled together and how the mechanism that allows to these different components to communicate, let's say, are coupled somehow. So in functionalist artificial system, the resemblance with the artificial system is very superficial. While on the other hand, with the structuralist models, the idea is that beyond sharing the same input-output specification, there is also a much more constrained resemblance between the algorithm or between how the system is built, how the artificial system is built, and the working mechanism that are known to hold for the natural system. Now, this distinction can be really seen as a spectrum. So between as a continuum. Sorry. So within this continuum, we can have in the middle between purely functionalist and purely structuralist models, a plethora of different models that have somehow an explanatory role with respect to the natural system that is eventually taken as a source of inspiration. And the interesting thing is that there are different kinds of explanatory models that we can attach to, let's say, such system based on the way in which these two elements, so the ratio between, let's say, functionalist and structuralist component within a complex system, because of course, in a complex system, we may have parts of this system which just try to mimic the same input-output specification of a natural system, but there may be other parts where we want to be much more closer to, let's say, the biological or the cognitive, let's say, phenomenon that we want to model. And I think this is the first important distinction introduced in the book. And another, let's say, element which is somehow underlying, which is an underlying assumption of the book, is why a cognitive approach is important. There are different reasons, but some of these reasons are indicated here. So the first one is that the gap between natural and artificial intelligence is still enormous. And this is true both for, let's say, narrow domains, even if in some specific cases there are superhuman intelligences. But in general, this statement becomes even stronger if applied to, let's say, the general approaches to intelligence. So if you want to have a system that is able to perform with the same kind of, let's say, structure of architecture, multiple tasks, we see that this is really a problem. The second reason is that there are a number of fields showing how only a machine-oriented approach does not really solve the problem that you want to solve in AI. And this is true, for example, for a number of fields like unsupervised learning, transfer learning, common sense reasoning, analogy-based reasoning, spatial reasoning, and so on and so forth. And another reason, which is indicated in the book, is that the use of a cognitively inspired approach, cognitively or biological. I mean, I'm using these terms in a sort of interchangeable ways, but we will see in a minute why. The idea is that we can use these artifacts, so this artificial system that we build by taking a cognitive inspiration, as a way to simulate, let's say, not only a kind of cognitive or biological phenomenon that we want to understand better, but also in an exploratory way. So this is the case of the so-called what-if hypothesis, okay? In an artificial system, I can test the dynamic of a theory that I'm going to implement somehow algorithmically. Other key points are of the book is that, of course, if you want to have systems that have an explanatory power, if you remember the loop of the first slide, we really have to look to the so-called structural models, which are realizable in different and empirically adequate way. Another important thing is that neural models are not necessarily more plausible than hybrid or symbolic models, since the explanatory role of these systems depends really on the way in which we enforce this structural constraint on the system that we are going to build. And the last point is the idea of using really this kind of system to computationally test the theories and hypotheses that we want to take into account, coming from human cognition or also from animal cognition. Another, let's say, contribution of the book is this minimal cognitive grid, which is a sort of very pragmatic tool, if you want, to provide a way to rank the cognitive or biological adequacy of artificial system where functional and structural components are coupled together by using these three elements, which are the functional structural ratio, the generality of a system, and the performance match. So how much a system match the performances of humans, for example, including also, however, not only the success cases, but also the errors and other kind of psychometric measures. The idea is that with this tool, we can really have a way to put also in connection different kind of system on this kind of 2D axis of cognitive system, which is also mentioned in the book. And with this kind of method, we can also see that, for example, some of the most famous AI systems today are not really cognitive systems. They are not cognitive systems because they they model a different level of abstraction, but in a functional way, the same kind of, let's say, a behavior that we are able also to have as humans. So they are functional replica. I'm using the functional in the sense expressed before. So they are able to somehow mimic the output that we are also, as humans, are able to provide when we have to answer to a questions on where we have to play, for example, a game. But they use different kind of mechanism and different kind of modeling paradigms that simply use different abstraction levels. Of course, these systems, as I mentioned, cannot have any kind of explanatory role with respect to how we are able to perform the same kind of, let's say, actions or the same kind of decision-making strategy, because they do not use any kind of heuristics or of mechanism that we know coming from the experimental psychology. And finally, and I will conclude here, I suggest that it is really time now to consider in a more detailed way the idea coming from Allen Newell of using cognitive architecture, so of using somehow software instantiation of cognitive theories that are able to, let's say, implement the invariant structure of the cognitive systems. There is a huge community on cognitive architectures, starting from the SOAR community initiated by Allen Newell, but there are also community around other cognitive architectures like Akhtar. There is also an attempt to merge the results of more than 40 years of research in this field, which is nowadays collapsed within the proposal of a common model of cognition or standard model of minds. And I really believe that now it's time to focus on the point of the integration of the different kinds of capabilities if you want to really make scientific progresses in the context of AI. And that's it for now. I mean, I will just try to stop sharing the screen. I have other things, but we can discuss them later.
Okay, so thank you, Antonio, for this brief presentation of the book. I suggest to have a very brief initial round of very brief comments on the book. So I cover the highlight of the book according to your view. So we can start by Karen. So let's start by Karen, please.
Okay, thank you. Well, for me, the fact that it's a comprehensive review of such a broad and complex field put forward in such an accessible way, and the fact that it provides an applicable framework for sort of quality control in an era where a lot of marketing, for example, uses a lot of our phrases liberally, and also that it actually frames what I do in practice. So it's really helpful to me in particular. In games and e-commerce, actually.
Okay, thank you. David?
Yes, I think Karen has stolen my my comments, I'm afraid. Yeah, no, exactly. I think, I mean, the key, the key point, I think, is the minimal cognitive grid, which I think is a really good explicit characterization of the dimensions on which we think about these systems. I mean, yes, I mean, I think a lot of people have those ideas implicitly, but I think Antonio has done a really good job in really sort of making that sort of explicit and allowing it as a useful framework to think about those. I think if there's a sort of three-dimensional cube rather than a two-dimensional, you can sort of plot clusters of these architectures on the three dimensions that he identifies.
Shiwali.
The other thing I think, which is, Antonio's waving?
No.
Oh, okay. The other thing is, I think that the clarity of the first two chapters, I think, in terms of providing a historical and a conceptual framework to think about the history and the space of architectures and artificial intelligence systems is really useful. I have a postgraduate course starting next year on cognitive science, and that would be an ideal, I think, introduction to sort of for postgraduate students to allow them to an idea of the space of various cognitive architectures and intelligent systems. Okay, that's me.
Great, thank you. Is there Shiwali? I was not able to I see that Shiwali is here, but I'm not able to see her.
Yeah, I mean, she's here, and but Shiwali, you should come close to the podium to talk with to broadcast with the entire audience. Okay.
Thank you. Thank you for inviting me here. And I think I find myself in violent agreement with Karen and David. I think it's a really comprehensive review, and it's a great review of the history of AI. And it's when I started, when I was back in graduate school, I did read a lot of these papers, and these were read over several years, right? So the papers that Antonio cites. And it was wonderful to read all of those put together in such a brilliant summary of what has happened in the field until now. And it's a great resource for undergraduate and graduate students who are just getting into the AI field to understand where it came from. Because if we don't understand where it comes from, it's hard for us to see where we're going. So it's a great book, a great summary review for that. And the second thing I really appreciated was this call to arms to define what would it mean for human rights systems, right? So I like the idea of defining the minimum cognitive grid, and I hope the community can get together and define that evaluation criteria.
Shiwali, sorry, I think you are not broadcasting to the entire, because if you move closer to the spotlight, yeah, you should find your video going orange somehow. And if you are orange, it means that you are broadcasting. Otherwise, I mean, only the avatars which are close to you can listen what you are saying. So, okay. Sorry for that.
How about now?
Okay, so you have to repeat.
Oh, okay. So I can do that now. So two main things to talk about the book. The first is this brilliant summary of history of AI. Like it was great to read all these references to these papers and the insights in those papers summarized in a brilliant way. And I had read those papers over several years in my graduate studies, right? So finding a great summary was wonderful. And it's really important to know where we came from, where the field of AI and cognitive science came from, to know where we are going. So without knowing where we came from, we don't even understand the direction. So this book is great for that, and I think it's a great resource for undergraduate and graduate AI researchers to learn what different people were thinking at different time points when they were trying to understand intelligence. The second point I really want to stress, and I really liked about the book, is the idea of the minimum cognitive grid and the proposal to use that as an evaluation of robust and flexible cognitive systems. Right, in the AI systems, so that's what my background is in AI systems. And it's really hard to measure progress unless you have an experiment and evaluation, right? Like otherwise we don't even know what we're building towards. So then proposal, I really appreciate Antonio's proposal for here is how you would measure progress. Right? And then hope the community can come together and define, refine the idea of minimum cognitive grid and really converge into identifying what it means to build a cognitive system. So thank you, Antonio, for writing this wonderful book. I enjoyed reading it.
Okay, thank you, Shiwali. So essentially, all good so far. So anyway, and I would like to enter more into the details of some of the comments. For example, for the people, so in my opinion, the user effort in this book is to try to make these two communities, the community of cognitive scientists and the community of people working in AI, start in some sense discussing, to start knowing each other. No, which is not so simple, of course, which is not so simple, and we need some kind of common ground. And maybe in this book there are some elements for common ground. So, because one of the problems is, for example, that if we have to develop a kind of AI application, do we need cognitive architecture or not? For example, today there is the huge employment of neural network, which are very far from the cognitive architecture. So the problem. So my question is, do we need the cognitive architectures when we have to develop an AI system? It can be useful or not. What do you think about?
Okay, who's going to?
Do you want me to start again? Yeah.
Yeah.
So Karen, do you want to?
Yeah. Okay. I'm just okay. Okay, so well, I think the obvious answer for all of us would be it depends on the domain of application and the task in hand. All my research is in human factors, the digital transformation of human factors and user-centered design. So it's absolutely imperative for me to work with cognitive architectures for machine learning and AI.
Of course. So, for example, many applications like Watson, AlphaGo, and so on, they do not need they do not have any kind of inspiration from cognitive science. They are pure engineering systems. Obviously, as you say, Karen, it depends from the application, of course. So, David, what do you think about it?
Yeah, I agree. Yes, if you look at the sort of spectacular rise of AI applications recently, you would say, no, it doesn't really. They don't really need cognitive architectures. But I think that they are quite limited into they're very sort of narrow, and I think they're probably working at the wrong sort of level. They're not conceptual in any way. They don't build up strong sort of representations that we would think of in cognitive science. So I think when you get to more cognitively oriented tasks, then I think the insights from cognitive science will become much more relevant. So, for example, if you look at systems like that try and understand narratives or read stories, they're incredibly weak at the moment because they have a limited knowledge base. And so I think when you want to gain insights from the value and relevance of knowledge, conceptual knowledge. And I think any sort of building an AI system that's to do that sort of thing will probably need the insights from cognitive science to see how to develop it.
Yeah, no, I understand your point. There has been the idea that for so many years that in order to be a real AI application, real working, there should be a huge quantity of data. So let's think about the psych example, the creation of such a huge semantic network, and so on. Anyway, yeah, so please. No, I was saying maybe there could be some space for cognitive science in AI. You rightly posed the question in relation to language, to translation, to linguistic application. This is in general a point where neural network maybe is not so efficient. And obviously another problem is the problem of transparency, which is a big problem that maybe could be where cognitive architecture could be
Yeah.
Shiwali, what do you think about it? We can't hear you. So do you think that the use of a cognitive do you think the use of cognitive architecture could be useful for in the development of AI systems?
I think there are two main use cases for studying cognitive architectures and continuing to study them. The one is to understand human intelligence, and as Antonio pointed out in his book, to generate explanatory explanations of why like what contributes to humans, intelligent problem solving, general flexibility, and things like that. And I know that Karen and David already pointed out that there are a set of AI applications where you do not need to investigate that question. But I think as we move on to new kinds of problems, for example, John Laird from the University of Michigan and other colleagues proposed interactive task learning, which is how would you program systems with new task knowledge through natural interactions, right? So as we move towards more complex problems, I think the idea of a cognitive architecture becomes more and more important because now you have to combine multiple intelligent capabilities in a single system. The second kind of problems, I think, where the role of cognitive science and cognitive modeling becomes important is where we are designing AI systems as tools for humans to use and work with to achieve their tasks, right? So now, if we do not, so for example, we can all imagine a tool that's working with designers to come up with novel designs. Now, if humans don't understand what the AI system is doing, why it's making certain decisions, it would be impossible for the human to adopt that as a good tool. So the AI system now must understand how humans represent information, knowledge, and what they find useful to be then able to provide them with the right set of information. And I think as AI systems evolve more and more, this would become the defining characteristics of successful AI systems is systems that model humans much better because now they're able to actively collaborate on different, decision points. And like recent call to arms around explainable AI and more natural interactive systems, they're all artifacts of that need that the community has, right? Like it's hard to adopt a complex decision-making device if you don't understand it. And so there's a lot of work that needs to be done by AI scientists, by cognitive scientists to figure out how to bridge this gap.
Yes, no, you touch the important point of understanding what the system is doing. So I understand that it's difficult to know what are the outcomes of a neural network, while it is more easy to understand what are the operation of a cognitive architecture. And the title of the book is Cognitive Design for Artificial Mind. So the artificial mind maybe should need some sort of cognition. And today, one of the important topics is the hybrid system. So the topic of hybrid system, where there is some sort of intermixing between symbolic and sub-symbolic systems. And maybe, in my opinion, this could be a possibility for the artificial mind. What do you think about? Do you think that there could be space for this sort of hybrid approach, or do we should think more tightly with the cognitive architecture approach, or some sort of more liberal approach?
If I can comment on that, because this also relates to the previous point, I will not, let's say, leave out the neural approaches from the field of cognitive science. They are part of the cognitive science. So let's remember the parallel distributed processing by McClelland and Ramelart. There are lots of connectionist models which are used in the context of computational cognitive modeling. So they are part, I mean, some of these models are part of the cognitive modeling community. Why? Because they enforce some structural constraints, what I call in the book structural constraints. Because when we talk about neural networks, we are putting together many different things. So a Boltzmann machine is different from a convolutional neural network, which is different for transformers, which is different from spiking neural networks, which are the ones which are, let's say, more biologically plausible. This is also a point that I make in the book. So I think that they have a place in the context of quantity science, together with the symbolic system and the symbolic approaches, because what we have seen in these last 40 years is that these two modeling paradigms are able to, let's say, cover different aspects of cognition. So some of them are more akin to, let's say, to model perceptual aspects, and other ones are able to better cover the aspect of high-level cognition and also social cognition, which is another, let's say, elements in which we really have not that much research done. So it is true that there are the current AI, let's say that if you look at Google DeepMind or to IBM Watson, they do not any kind of inspiration, do not take any kind of inspiration from how we solve the same kind of task. But I mean, the point of this system is are they really, let's say, able to generalize these approaches? If I can, and my answer is no. Is not just because they have, let's say, this problem of not having any kind of grounding on the kind of, let's say, literature that is known in the context of quantity science. So if I may go show you this slide, because an important element of this of the underlying, let's say, frameworks of this system is that they make some very non-human errors. So this is an example from IBM. This is the IBM Watson system answering to this query.
It's the second largest for a World War II battle. 30 seconds, please. Good luck.
Okay, this is the topic. The topic is US cities. These are the two human contendants, and then there is in the middle the IBM Watson system.
We come to you, Ken.
Okay, let's see.
We come to you, Ken.
Okay, so the first contendant says that the answer is Chicago.
And you wagered $2,400. That doubles your score. 4,800. Down to Brad now. He had 5,400. I have to feel that he came up with a correct response. Did he?
Okay, the second contendant also provide the answer Chicago.
$5,000 takes you up to 10,400. Now to our leader,
and Watson, I remember that the topic is US cities.
681. And the response was
Toronto.
Toronto.
Okay, so this is a very, let's say, example of how these systems fail in a way that is really incomprehensible to humans. And another example that we have, for example, in convolutional neural networks, is the fact that the kind of representation that they have is really different from the ones that we have studied, let's say, in classical, let's say, cognitive vision, and this lead to incredible errors. So this one is a very famous one done by Google Photos, based on convolutional neural networks, but we also know that it is possible to fool quite easily this kind of networks by training adversarial networks that can learn which kind of pixel in an image to change in order to change completely the classification of a system. So these are two examples which are very famous that show how it is important to integrate also, let's say, a cognitively inspired approach in order to avoid this kind of errors. These are very bold errors, and let's say, decrease the kind of the trust that we let's say put in this kind of system. If you remember, at the end of the IBM Watson system, there was this made by the public, because they were it was incredible for them to have the Watson system that was winning the game, to have this kind of errors. So this is the first point. Then very briefly, I think that the integration between symbolic and sub-symbolic models is really a key. I mean, if there is something that we know from computational cognitive modeling, but also from AI, is that there is not really a winning modeling paradigms, okay, in the science of the artificial, in order to use the expression by Albert Simon. So we need to find a way to integrate the strengths of all these paradigms, and I think that cognitive architectures can really be, let's say, a platform through which these elements can be connected. But I want to hear what the others have to say about that.
Yeah, I mean, I think it's exactly right. I think if you look at human perception, it's not just a bottom-up data-driven process. We know that there's a huge amount of knowledge that about expectations and that is used to interpret that data. So I think whatever the system, you need these bottom-up neural network approaches on their own, I think, are not going to get the sort of human-like cognition, even at a perceptual level, that we enjoy. So I agree entirely.
It becomes a very high risk type of approach to complex data sets, in my opinion. We know that, for example, more black people than white people are arrested in London, and what does that tell us? We can't just dig into the mathematics and get any sort of reasonable model that accounts for the complex human social scenarios behind how that occurs. So it becomes, for me, that we shouldn't be using a kind of mathematical approach to complex human data modeling anyway. Of course, a computer can win at chess. It's a rule-based game. That'd be a bit contentious there. So I would say that we have to look at humanistic models from the cognitive sciences, from psychology, from sociology, from rhetoric and philosophy. Yeah. And we have, and this book for me sets a footprint from where we can start.
I agree completely with Antonio, David, and Karen that we do need to understand the integration between sub-symbolic and symbolic approaches. And as Antonio was pointing out, that for certain kinds of problems, symbolic systems don't just lend themselves to the solution, right? So, like if you're building a general purpose intelligent robot, then, and I'm coming from the background and trying to build these robots using SOAR, like we did find that SOAR mechanisms were incapable of addressing the complexity of perception that a robot would face. So then we then were driven by like, how do we build this robust system, and then we use deep neural networks and other vision techniques to implement on robots. I think the utility of having a cognitive architecture is it gives you precise hypotheses around what can and cannot be done and what can and cannot be built. And this is how the design space would integrate towards more robust systems. I think the second question, which is interesting, which personally I haven't pursued, is how do different cognitive modules arise in the biological substrate, the neural substrate that humans have, right? And some scientists are actively trying to explore it. So what does it mean for an episodic memory to be built using neurons? And I think those are also interesting questions that lead to more understanding of how symbolic and sub-symbolic systems can be brought together.
Yes, but nevertheless, in the common AI textbook, today I received the more recent copy of the Russell and Nordic book. But the role of cognitive architectures is very teeny. So there is only a few pages on cognitive architecture. So why do you think it is? I can say it is not the main topic of our common textbook of AI. So what is the motivation?
Well, I just think.
I mean, go ahead, David.
Sorry, I was just going to say, I think that they're coming from two different goals, really. I think people reading that AI book are more interested in engineering solutions and optimal solutions. Suboptimal human solutions, I don't think are really that relevant to that sort of goal as it stands at the moment, because they're interested in developing relatively narrow, sort of real expert systems in a particular domain. I don't think the goal is to, at this stage, is about artificial general intelligence. When that becomes more of a reasonable, or a goal that could be reasonably aimed at, then I think then cognitive architectures may be more seen as being perhaps more relevant. Sorry, Shiwali.
Oh, I agree with you. I think like the AI community has evolved, and there is now a wider set of problems that can be solved without there being a cognitive architecture motivated solution. And I think the other part is that it's just hard, right? So to understand like a complex architecture like ACTAR, you have to really understand what, the rule-based systems are, what learning would mean, what does memory have to play a role. And these are like really big topics to cover in a general AI textbook, which tend to focus more on algorithms. But it is a challenge for adoption, that people do now have to learn a very complex piece of technology to then be able to understand what to do with it. So it's a challenge, but as I said, like as there are more interesting, complex problems that people start studying, I think these architectures would start to make a whole lot of sense.
I think a lot of people designing AI systems wouldn't want the systems to fail like humans do. Forget things. Forget things like people do because of not enough activation or whatever. You want your system to succeed at all times.
It's quite interesting though, isn't it? Machines do a set of tasks really well, and people do a set of tasks really well. So the art is really working out what degree of convergence is required for the task. Yes, we do have failing memory, but we have really good intuition and empathy. Echoing. I'm working with a judge who's developing a PhD proposal on how AI might augment the judiciary. And from where we're starting, the answer is it's impossible because of how much heuristics go into her body of knowledge. So again, we're looking at a spectrum, whereas, machines do lots of things brilliantly, and they're not as, we don't want reflection and intuition and empathy in many mechanistic decisions.
And this is a good point. Essentially, AI systems do not take care essentially of emotion or empathy or whatever, while the people coming from cognitive science, of course, the emotion and motivation are essentially more important. So, the general problem is that if we have to build an artificial mind, as the book says, do we need to know what is how the human mind works, or not? So, or can we build an artificial mind without taking into account how the human mind is made up? So it's not so easy to have a general answer to a general question to this answer, of course.
If I can make sorry.
Intelligent, of course.
Okay, if I can make a comment, on that, I mean, if we look at what we are in the context of AI, so the question that I'm going to pose is: are we really happy with what we have? What do we have? We have very narrow, specialized systems that are able to be intelligent. So I'm asking what has been the role of AI in facing the COVID pandemic, for example. It has been close to zero, because apart from the propaganda, we were not really able to build systems that were also in very specialized, narrow domains, able to cooperate with human operators. In order to cooperate with human operators, you have to somehow have a model of what human operators, for example, want to ask you, and you have to be able to provide what is needed. Okay, so and if we look really at these pandemics that is forcing us to have this discussion in this virtual room, right? So the technology that we have is really, let's say, not sufficient. So I mean, we can write whatever media piece on the brilliant technology that we have, but this technology is not scalable. Look at also at the language models that are developed by using these gigantic networks are not scalable. They use an amount of energy which is incredible. So why should we look at how we are able to address the same kind of problems with much less data and in a much more, let's say, flexible and robust way? Because we are, let's say, animals that are able to make a lot of tasks with a very low energy consumption. Is also this issue that should be taken into account. It's not just a matter of performance. So how I can play well to Sudoku. If I'm perfect in the game of Sudoku, then I'm a complete idiot in all the other things. Okay, would you say that I am intelligent? I don't know. Probably not so much. So this is the real point of integration. So there are a lot of practical implications in trying to really address these integration issues, and we as humans or other animals are still the best systems on this planet that are able to let's say, make a variety of tasks in such a good way.
And use any sort of machine learning, you have to have human-centered models about human behavior and human decision making. And I did actually do a talk for the Institute of Engineering Technologies called The Digital Transformation of a Pandemic, which doesn't, I'm not an artificial intelligence expert, but I do use a lot of machine learning and as insights into human behavior. So I'd like to know what anybody thought of that if you dig it out later. Might have some.
There have been on how robotics affect the pandemic situation. However, there not be any kind of serious result, in my opinion. So there have been many manifestos, many good intentions, and no, I wanted to ask, but taking into account this fact, so coming back to the idea of the artificial mind, in my opinion, the artificial mind should need a kind of artificial body. So, do you think that there should be, in your book, Antonio, you don't talk essentially to the cognition in terms of embodiment? So I am a roboticist, so I think that the role of embodiment is important in terms of cognition. What do you think about?
Yeah, I think that in the context of quantitative science, this is kind of taken for granted. But it is also true that you can have artificial models of cognitions which are not embodied. And most probably you can also have natural, let's say, natural conditions without the control of the body. So let's think as people which are locked in and are paralyzed, that cannot move any kind of muscle, okay? But they still are able to, let's say, somehow by using different kind of neuroimaging techniques, it seems that they are able to activate the parts of the brain which are not damaged by a disease or by other issues. So would you say that they are not intelligent? So I think that in the, let's say, standard case, it is important to consider the role of the body. And I mean, of course, robotics is a crucial part of AI, but also of the cognitive systems community. So most of these cognitive architectures are applied in the context also of robotic applications. But the idea is that it is not, let's say, the only element that you should look at. So, in other words, to use the wording of the book, you may have a structural model of cognition, which is not necessarily, let's say, embodied, at least in principle, but then you can, let's say, try to use, for example, that kind of model within a robotic platform by using, I don't know, cognitive architectures. I've seen that there are some questions probably also in the chat. Okay, I don't know if you can all see.
I agree, Antonio. I was going to say, I think in the ACTR community, there's been a general move away from disembodied models to more and more models that do take physical constraints, and I think there have been some more trying to embody ACTR in robots. I think Shiwali's work with SAW, I think, is an excellent example of how that has been done as well. So yeah, I think they do imply, particularly if you're trying to model human data at a very narrow, fine grain, you know, physical constraints do, are important, because they will constrain, in terms of timing and how you do physical and cognitive actions in parallel. So I think from a cognitive modeling point of view, then definitely. From a robotics point of view, I guess that's a different aspect.
I also wanted to it's important to understand that human cognitive architecture evolved so that humans could deal with their physical space much more efficiently and intelligently, right? So it has happened that through evolution, the same cognitive apparatus can now be used for much more abstract thinking. But I think the presence of a body was important, at least for the structure of the cognitive architecture that we have. And now with those components, we can do many more different types of abstract tasks. But I think it's an important thing to sort of just keep in mind, even though we can talk about embodied and non-embodied systems.
I think there is a question probably also from the public. So Peter wants in chat has written that he wants to make a question. So Peter, please join the.
Yes. So
okay.
Antonio,
okay.
Chapter 3 is mostly about
Peter,
different concepts. Do you hear me?
You have to move towards the spotlights. So the podium. Where I was here, I don't know if you, exactly. Okay, there is Peter. Okay, Peter, you can move towards the podium and try to see whether you can talk. So please reach the podium. You have to move with the avatar.
Do you hear me now?
I can hear you, but you are not broadcasting to the entire room. So you can move where I am if you want. I don't know if you can see my avatar, because from here you can broadcast to the entire room.
Peter, if you can move to an icon where there's a megaphone.
Exactly. Move where there is the megaphone.
I think you'll only broadcast to the speakers. If you go to the megaphone icon a bit, and you'll broadcast to the audience as well. That's it. Yes.
Do you hear me now better?
No, you are not really broadcasting.
That's it.
Okay, now, okay.
What about now? Great. I'm learning. So chapter 3 Antonio, is mostly about the different concept of rationality. And you start with the classical rationality, then Simon, bounded rationality, Anderson, discourse rationality. So how do you feel? Do we have a single rationality concept that we should incorporate into cognitive models, or depending on the different problems that we approach, still we can use occasionally the classical method, classical rationality concept? So how do you think about this, the changing description of rationality models in terms of pragmatical applications?
Okay, so this is a great question. Okay, of course, this also depends from the kind of application that you want to build. I mean, if you are in the context of quantitative modeling and you know that you are not going to use any kind of optimal based decision-making strategy, then you have to necessarily implement in your system bounded rationality, let's say bounded rational models. A bounded rational model. So you have to consider which class of algorithms to implement within your system in order to allow it to make a decision. If you are in the context of developing an AI application, you are probably just interested in having optimal models, but that as we have seen that as we were discussing before, this optimality in very narrow application does not really scale well, because one of our strengths somehow is also the fact that we are bounded. So our boundaries from a cognitive and biological point of view are also our strengths, because we have a way to let's say somehow being suboptimal, okay, being satisfying decision maker, but nonetheless we are able to deal with a lot of different kind of tasks by using this kind of very limited let's say brain and cognitive architecture that we have. So I don't know if this satisfies your answer. I think that as scientists we are only interested in as scientists and cognitive modelers, we should go towards models of bounded or bounded rational agents.
Thank you, Antonio. It was very good, and I like the book very much. Congratulations. And apologies, I leave soon. So thank you, and bye-bye.
Thank you, Peter. Thank you very much.
Thank you.
I don't know if there are other questions.
Maybe Riccardo wants to say something.
Hello to everyone. Are you listening to me?
Hi, Riccardo. Yeah, we can.
Okay. Thank you. I'd like to say that I agree with your idea that at some point you need to mix symbolic and numeric approaches. Are you listening to me? Because it's so.
Yes, yes.
Okay.
We can hear you.
Okay, so one point that I'd like to say is that, as I believe Shiwali already told, that we should make this connection to the real world that is very much something that in robotic systems we will be having the opportunity of doing. And so this connection that is possible using some kind of visual spatial system that turns information into spatial locations or spatial objects, and connecting those objects or these things in the world with symbols is of ultimate importance for cognitive architecture. And so I believe that one of the most important things in a cognitive architecture is exactly this possibility of integrating many different kinds of representations or information that we have about the environment or about the world, and using different techniques in order to reason with this information. So I believe this is a quite important aspect, and maybe the new developments that we are going to see on this field of cognitive architectures will be addressing this connection to the real world in the visual spatial kind of representation. Okay, that's basically that. Thank you.
If I may, I was a very long time ago, I was part of the complexity and design research group at the Open University with a lot of roboticists and transport systems designers and all sorts. And we found a lot of traction by going really hybrid and collaborating with all sorts of different people from different disciplines to see, you know, it's almost like having a trunk of ideas and seeing which ones might solve which problems. For example, we worked with a lot of dancers to understand the notion of embodiment. And I've got videos of mathematicians trying to embody problems and dancers helping them understand how movement can do that. And it sounds a lot less ridiculous now than it did 15 years ago. So a will to hybridity and collaboration, I think, will be very rich theme.
Yeah, I mean, as you have experienced it, so it's always complicated to work with people with different kind of backgrounds. But I think that we really need to go there. So otherwise, we are keeping to have this kind of idiot savants that, let's say, are only able to perform, are very, very brittle. And I think that we also should not run the risk of having in a sort of revival of all the old behaviorist claims that were, let's say, in auge in the last century in the context of psychology. And for example, nowadays there is this new paper from DeepMind about reinforcement learning. Okay. So the idea is that reinforcement learning is enough. This is, I think, reward is enough is the title of the paper, which appeared in Artificial Intelligence. So this is just a revival of a very, let's say, classical behavioristic claim that, of course, was already supported by, let's say, a part of the people that work in AI. Usually, these kind of claims are often, let's say, very, very easily, I don't know how to say, doomed, because this was also the claim a few years, 3 or 4 years ago about deep learning. So deep learning is able to do everything, but this is not true. Now the claim is the reinforcement learning is able to do everything, but of course this is not true, and we know the reason. So the idea is that, I mean, if we go back in the kind of the historical concept of AI, we already know that there are some paths that are really not interesting to pursue. We need to find a way to integrate deep learning, reinforcement learning, also causal inferences a la Judea Pearl within a system that is able to help us as a sort of co-worker with the human. So this is the missing part. And in order to do that, Karen, I mean, I agree that we have to find a way to really mix the experiences, the knowledge. So we need engineers, computer scientists, we need philosophers, we need sociologists, in particular because these systems are assumed to interact. So with us, okay? We are not, I mean, I think that we are interested in this kind of approach when we have to build systems that should interact with humans. If you want a machine that also needs to interact with another machine, you probably don't need any kind of quantitative approach. So this is, let's say, not something that you need always, but in some cases you really have to look a little bit into the kind of knowledge that is already there in a sister discipline of AI, which is cognitive science, and that we should really integrate in AI systems. I don't know if there are other. If Antonio wants to. Antonio, we can't hear you. Okay, now we see you, and now we can hear you.
Can you hear me? No, I was wondering whether there are other people that wanted to talk. I have one, let's say, another question is concerning the minimum cognitive grade. So you pose a lot of attention in this method of evaluation of cognitive systems. But do you think that they are really useful? This kind of system could be useful or not? What do you think?
I'm struggling to hear what was said there. It was very crackly. I try
to repeat. I was wondering whether the methods for the evaluation of cognitive systems are like the minimum cognitive grade, can be really useful or not. What do you think? Can you hear me?
Okay, this is a question for the panelists, I suppose, right? Or for me?
Yeah.
No, it's for you and for the panel.
Somebody put the question out in the chat because I missed it, I'm afraid.
Okay, I was able to.
Okay. Antonio, can you hear?
Yeah, I mean. Okay, I was able. Okay. Okay, I think I was able to hear the Antonio's questions, but please, Antonio, if you can write it in the chat, because I think that the others were not able to listen. So the question was about the minimal cognitive grid and the usefulness of this kind of let's say framework for evaluating different kind of AI system. I think it is important to have this kind of tools, of pragmatic tools, if you want, because it is important the kind of explanation that you want to attribute to the behavior of an artificial system. So if you are able to somehow decompose the way in which a complex system is usually built, you can also see which are the components of a complex system to which you can, for example, assign a mechanistic explanation, or which is the one that we are really looking at in the context of quantity science, or where are the other parts of the system where you can attach, for example, other kinds of explanation. So the landscape of, let's say, the explanatory possibilities is very huge. And this is, for example, something that comes directly from the philosophy of science. So that's why I was talking about the importance of connecting different kinds of knowledge and of fields. So these different types of explanation is not something that was categorized by me, but there is an entire literature in philosophy of science talking about the different kinds of explanation that we can, for example, also use in the context of computational models of cognition. And in this way, you can also rank, let's say, the explanatory power of different systems. Of course, if you have a system which is purely functional, so that does not take into account any kind of, let's say, structural insight from quantity science, I mean, this is something that you can completely avoid. But I think that for the purposes of the book, it was interesting to have a system that at least tried to mix some functional components with other that are more, let's say, closer to the biological or cognitive accuracy. And
I think, I was going to say, I think that characterization of dimensions, I think, is a useful one, in that you can, it sort of, it partitions a space, or it defines a space in which you can then have individual architectures or approaches as points in that space, and you can see where they are, how similar they are. You could see where they cluster. For example, a lot of cognitive architectures are very similar mechanisms in terms of cognitive control, some sort of like production system mechanism, where you can see where, you know, if you attempted to plot all of these architectures in that space, you can see the sort of similarities in terms of their assumptions of various different mechanisms. And you might then be able to identify which of these mechanisms may well be a really important one that underlies a lot of these different systems. And then, you know, and you can see where different architectures or different approaches, how similar they are to each other, and how they differ in terms of their assumptions. And it gives you a really nice clustering of approaches on these various different dimensions. So I think it's valuable, very valuable in that respect.
Okay, thank you. Shiwali and Karen, what do you think about it?
I definitely agree with having or spacing out what progress would mean in the cognitive systems is very useful, and that's why I said, like, the minimum cognitive grid idea. I really appreciate outlining, sort of laying out what would mean progress in developing more robust cognitive systems. I do want to sort of highlight that AI systems, like, there's a whole philosophy in AI systems design where you first generate a data set and then the experimentations, and then you iterate over the methods to then make progress. And that leads to this race to arms on super specific problems. Like, it's things like, you know, the common sense reasoning tests or things like that. So I really appreciated that the book was trying to say that instead of this specific experiment or the specific data set, we have to look at the structure and the function, the structure, the behaviors and things like that to be able to make progress. So thank you, Antonio, for really specifying what we need to start measuring these systems.
Yes, and it's similar for me, really, in a completely different domain. As a practicing industrial designer, I've stood in presentations in very large companies where this is our cognitive model that does this. Now I'm thinking, I'm sure this is a cognitive model. So it's, you know, it's useful and important to differentiate between fundamental types of machine learning, different levels of sophistication in syntactic, semantic, and cognitive artificially intelligent systems. I think it's, I'm looking forward to trying to apply it to some of what I do, but that's going to take me considerably longer than I've had so far. But I will be doing it because it's so useful. So thank you.
Okay, so I think that it's time to close our interesting roundtable. And so I want to ask to each of you one final word about the book. So let's start by Shiwali.
I think a great for new AI researchers to read as a part of their coursework. I like that it's short and pithy and it covers a lot of history. So it gives someone a really good background to then start investigating their own research questions, right? So it talks about where we came from, it talks about what would progress mean, and it connects it to different examples that exist. I think any student of cognitive architecture, cognitive systems, and AI systems in general would find a lot of value from this book.
So thank you, Shiwali. David, can you say
yeah, I agree with all. I also think there's been a lot of discussion in the cognitive architecture community, and more broadly, I think, about the limitations of AI, the AI, machine learning, and approach or integration of those. I think actually this book really sort of does a very good job of bringing those arguments to the fore and sort of making a very clear exposition of them that will be really useful and useful. I think it, hopefully it will be widely read, and hopefully it will engender further discussion, because it's an important argument, which I think will be valuable over the next decade.
We can't hear you, Karen. You are muted.
I could hear.
Okay. I was just drumming up for a really good ending. But I can tell you unequivocal, for brain-to-brain communication, echo.
Okay. And now, Antonio, you are muted. I don't know what is happening.
Your final word about the book.
Okay. So, I mean, I don't. I mean, never ask the author of the book to say final words about his book. But no, I mean, I just want to say thank you to all of you for this discussion. Shiwali, Karen, David, and also to you, Antonio, for moderating this discussion. It was the first time here in this Gather Town thing. I hope it was possible to follow also for the people in the audience. But I mean, I just want to thank everybody, and I think that as I hope that this will be one of the many discussions about some of the elements of the book. As it emerged from the discussion, some of the elements are mainly historical, but there are some new issues like the minimal quantitative grid and other new proposals that I hope will be discussed and improved. So this is not, let's say, the final point. This is a starting point also from my perspective, from my research perspective. So I really look forward to have much more feedback and this kind of discussion also in the future. So thank you, everyone. Okay, so thank you really everybody for staying here until the very end.
Thanks everyone.
And yeah, see you. Thank you guys. Thank you,
Bye-bye.
Antonio. Ciao.